Okay, well, so now we're into implicit differentiation. And so the whole idea is that it's for expressions where you don't necessarily solve for y explicitly. Instead of saying y is equal to a function of x, you may have something like number 2, which is x squared minus y squared is equal to 16. And this actually is the equation for a hyperbola. So it isn't really a function. Notice it doesn't say find the derivative of the function, it just says find the derivative, or find dy dx, which is still the slope of the tangent line, but it's... Okay, so what do we do? So basically what we're doing is d dx of x squared minus d dx of y squared is equal to d dx of 16. So we just take the derivative of each term with respect to x. Now the ones that involve only x are simple. They're just what we've normally done. So the first one becomes x squared, the constant becomes 0. Now the tricky part is this, where you have a y. And the way you deal with that is that you do it normally. So you'd say, oh, derivative of y squared is 2y. But then you put either dy dx or y prime. I'll put y prime. And that's it. Okay, normal plus y prime or dy dx. And then you solve for y prime. So the thing you do is you move all the terms that don't involve y prime to the other side. So we get negative 2y times y prime is equal to negative 2x. So that becomes negative when you move it over there. And then we solve for y. Once we've got all the terms involving y prime on one side, we factor out normally the y prime, but in this case there's only one term, so you don't really need to factor out. So you get y prime is equal to negative 2x over negative 2y. And you simplify it by canceling out negative 2's, and you get that y prime is x over y. Again, this is the slope of the tangent line. You need both x and y values in this case, not just the x value. Okay, just check her out here. X over y. Okay, that's it. Okay, number 3. X to the 1/2 plus y to the 1/2 equals 0. I have no idea. Oh, is equal to 9. I don't know what the heck this looks like. What the function looks like. We could probably use, you can sort of solve for it, I think, explicitly. But anyway, that's not the point here. We're just going to take the derivative. So again, you take the derivative of each term, and I'm just writing it out to emphasize that we are taking the derivative with respect to x, not with respect to y. So the derivative of a constant pausing because my thing just turned off for no reason, my pad. Okay, the derivative of a constant, no matter what the variable is, the derivative is always 0, so we can do that part. The derivative of x to the 1/2 is 1/2 x to the minus 1/2. And the derivative of y to the 1/2 is 1/2 y to the minus 1/2 times y prime. That's the difference. Doesn't matter what this argument is. You can have y to the zillionth power, and you'd have a zillion times y to the zillion minus 1 times y prime. So don't have to worry about thinking about it. Just put y prime down there. Okay, so we take 1/2 y to the minus 1/2. Y prime is equal to negative 1/2 x to the minus 1/2 power. So I've moved everything that doesn't involve y prime to the right-hand side. It just means changing the sign. You can see the halves cancel out. You can do that right now. So solving for y prime, you get a negative x to the minus 1/2 divided by y to the minus 1/2. And then you can switch them around because move this to the numerator and it becomes x to the 1/2. And this one going up to the top becomes y to the 1/2. And y to the 1/2 is the square root of y, and x to the 1/2 is equal to the square root of x, which, because they're both having the square root taken of them, you can have the square root of y over x. So the derivative, or the slope of the tangent line, is negative the square root of y over x. Okay, round number 6. So we're getting a little more complicated because we have products of two things. So we have x squared y plus y squared x is equal to -2. So these are products, and you just use the regular product rule. So what's the product rule? We'll apply it to this first. You take the first term, multiply it by the derivative of the second. And when you take the derivative of y with respect to x, let me write that out again so we're being very plain about this. Derivative with respect to x of x squared y plus derivative with respect to x of y squared x is equal to the derivative with respect to x of -2. Okay, the last part's easy, 0. Now here you have a product. So we're going to take the first term, x squared, times the derivative of the second. You might say, well, that's 1, but that would be true for here, but it's not true for here. So the derivative of y is y prime. Okay, then we take the second term, which is y, and we multiply by the derivative of the first term. Because it's x, and we're taking the derivative with respect to x, the derivative is 2x. Okay, do the same thing on the second part. So we take the first term, y squared, multiplied by the derivative of the second. The derivative of x with respect to x is 1. And then we take the derivative of the second term, which is 2y, y prime, and we multiply by the second term. So it's the same here. When we took the derivative of the first term, we got 2x. When we take, so the derivative of x squared is 2x. The derivative of y squared is 2y times y prime. That's the key thing. Okay, notice that this term involves y prime and this term involves y prime, whereas this one does not, and this one does not. So the two red underlined go to the other side, and we keep these on the left-hand side. So we get x squared y prime plus 2y y prime is equal to negative, and I'm going to go ahead and rearrange those, 2xy plus y squared. So you can see I've got y prime, no y prime. And it should be, that second one should be negative. Okay, so that's the first thing you do. Move these terms to the right-hand side. Next thing is you factor out y prime. So you get y prime times what's left, x squared, what's left, 2y. We just leave the right-hand side the same. And then you solve for y prime by dividing both sides by this. So when you divide this by itself, you get 1, and then in the second case, you get this expression. And typically, you can't simplify these things. So you just leave it as it is, and then just plug numbers in if you want to find the derivative. So that was number 6, and then we're just going to check. So it's, well, they did simplify it a little bit. They factored out a y, a negative y. So if you factor out a negative y, you get 2x minus y, or 2x plus y, or y plus 2x, doesn't matter. And if you factor out an x in the denominator, you get x plus 2y. Okay, so this x squared becomes x, 2y becomes I'm just looking here. Did I mess something up here? Y prime x squared 2x. I think I forgot something. Oh, I left something off here. So from right here, there should have been another x. So let's fix that. Plus 2xy. So when I factor out y prime there, I'll get to xy. Come down here, I get another x. So I can't factor out an x. So when I factor out an x, this becomes x, and this becomes 2y. Okay, so that's it. Okay, we're on number 9. So we have, it's very similar to the last one, just a little more complexity. Okay, let me just make sure I got everything right. Okay, that's good. So again, and you don't need to write this out every time. I'm just doing it right now, just so that you can see where all this stuff comes from. But if you can just, if you can take the next step without having to write all this stuff out, that's fine. Oh, forgot to do the last part. Okay, so that's 0. This can get fairly long, so I'm going to do it fairly, I'm going to do it as small as I can. So the derivative of x cubed is 3x squared. Okay, that one was easy. Now the second part, we have this product. So you're going to have 3. Okay, so you're going to take the derivative of the first term times the second term plus, so notice I'm multiplying both by 3. So I'm just looking at this part right. So then you take the first term times the derivative of the second, which is just y prime in this case. So that's x, that expanded out. 3, derivative of x squared is 2x, multiplied by y plus 3 times x squared times the derivative of y, which is y prime. Okay, the next one, we have 2, and the derivative of x is 1, and the second term is y squared. And then we add that to the first term times the derivative of the second term, which is 2y y prime. Now we're going to multiply all this stuff out and see what we can see. So we get 3x squared minus 3 times 2 is 6, minus 6xy, a negative sign, so we get negative 3x squared y prime. Okay, 2 times 1 is 2, so we get 2y squared, and then the last one is plus 4xy y prime, and that all equals 0. Make sure the key here is you got to understand how we get between these steps. So don't just say, oh yeah. You got to really think about it, because you're going to have to think about it on the test. Okay, now let me underline the ones. This involves y prime, and this involves y prime. These 3 do not involve y prime. So we're going to rewrite it. Move these the green ones to the right-hand side, and keep the blue ones on the left-hand side. So you get negative 3x squared y prime plus 4xy y prime, and that's equal to negative 3x squared plus 6xy minus 2y squared, and the signs change. This becomes negative, positive, negative, negative, positive, negative. Okay, then you factor out the terms. Factor out y prime. So what you have left is negative 3x squared plus 4xy, and the right-hand side stays the same. And then you divide both sides by that. So you get negative 3x squared plus 6xy minus 2y squared, all divided by negative 3x squared plus 4xy. So, let me just check that out, make sure it's right. 6xy minus 3x squared minus 2y squared, all divided by 4xy minus 3x squared. So they just rearranged the terms. What they did is put the positive term first and then put the negative terms second. And you can do the same thing in the denominator. So there you go. That's the answer. Okay, we're back to problem number 11, just to give some practice with the trig functions. So we get sine of x plus 2 cosine of 2y is equal to 1. Again, this is only a function of x, so the derivative of the cosine is the cosine. Then we have the constant times the derivative of the cosine. The chain rule tells us that we need to bring the 2 out. The derivative of the cosine is negative the sine. Keep the argument the same in the sine times y prime is equal to 0. So let's go back. This is just straight derivative. 2 is the constant. From the chain rule, this 2 comes outside. You have a negative sign because the derivative of the cosine is negative the sine. You keep the argument the same. And then because we're using implicit differentiation here, because we're taking the derivative with respect to x and the variable is y, you have to put the y prime there. Okay, so let's, 2 times 2 is 4. You have a negative sign, sine of 2y times y prime. So that's all that stuff. And then we can move the other stuff to the right-hand side. And then we solve for y prime. So y prime, negative the cosine of x divided by negative 4 sine of 2y. And then you can get rid of the negative sign, so you get cosine of x divided by 4 sine of 2y. That's problem number 11. So just go check. Cosine of x over 4 sine of 2y. That's the correct answer. Okay, we're moving on to 17. So it says find 2 explicit functions by solving the equations for y in terms of x. Sketch the graph of the equation and label the parts given by the corresponding explicit functions. Differentiate the explicit functions and find the dy dx and show that the result is equivalent to that of part C. So there's a lot of parts to this. So the first thing says find 2 explicit functions by solving the equation for y. Okay, so what does that mean? Well, we move all the stuff that doesn't involve y to the right-hand side. And then we take the square root. And so one solution is plus or minus the square root of 16 minus x squared. And the second, so we'll call that y sub 1, is y sub 2. It's a negative, so you have plus or minus the square root. So that's where you get the 2 functions. We can't just say plus or minus, because that's really not in this case, because we're going to plot these things. So let's write those down on a piece of paper so we can plot it without having to come back. So it's the square root of 16 minus x squared and minus the square root of 16 minus x squared. Okay. So let me minimize that. Get my graphing program up and running. Stop sharing, start sharing. Okay, so there's the graphing program. And so one function was positive the square root of 16 minus x squared, close parentheses. The second one was the square root of 16 minus, or negative the square root, minus the square root of 16 minus x squared. Okay, so let's see what that looks like. It's going to look like a circle or an oval. Actually, it should look like a circle, and it's just because of the way this thing is shaped as far as the scale is concerned. So let's just see if we can. Here you go. So now it's a circle. So the positive square root is on the top, and the blue is a negative square root, and each one of these separately is a function, but together they're not a function because you wouldn't pass the vertical line test. But the red part would pass, and the blue part would pass separately, but not together. Okay, so that's what it is. It's a circle. So if you were to find the, so let's go back here to. Let's go back to that. So the third part, they're asking to find the differentiate the explicit functions. So you're going to use the chain rule. So let's just say f of x is equal to positive the square root. And negative the square root is pretty much the same, except you just change the sign. So we'll do one and kind of assume the other. So what you would say is f of u is equal to the square root of u, and u of x is equal to 16 minus x squared. F prime of u is 1 over 2 times the square root of u. U prime of x is equal to negative 2x. So f prime of x is equal to negative 2x divided by 2 times the square root of 16 minus x squared. You can see the 2's cancel out. And so the derivative is negative x over the square root of 16 minus x squared. So that's for the red curve that we had in the previous example. If we looked at the other one, let's say it's g of x is negative the square root of 16 minus x squared. G prime of x is just x over the square root of 16 minus x squared. I just took the minus sign and made it into a positive. So those are the two explicit, and we can apply this to the red curve, and then we can apply this onto the blue curve. So part D is we're going to use implicit differentiation. So we get x squared plus y squared is 16. So when we explicitly differentiate that, we'll get 2x plus 2y, y prime, is equal to 0. And so if you solve for y prime, you'll get negative 2x divided by 2y. Okay, move that to the right-hand side, becomes negative divided by 2y. And you see the 2's cancel out, you get negative x over y. And you say, well, that seems kind of strange because that doesn't look like this, but remember y is equal to plus or minus the square root of 16 minus x squared. So if I plug that in there, I plug that in for y, I get y prime is negative x over the square root of 16 minus x squared. So it does work out. And the way the sign changes is when y is positive, then this is the denominator is positive. When y is negative, the denominator is negative, and that's what basically what's happening here, where we go from here to here, because this one is where y is positive, and this one is where y is negative. So they are the same, and they are equivalent. So. Moving on to number 22. So these are these problems we've done before, where we are looking for the, well, we're just evaluating the derivative. So we're looking, what is the exact slope of the tangent line to these curves at point x equals 1, y equals 1. You can see when x equals 1, you get 1 squared, which is 1, and then you put in positive 1, you get 1 minus 1, which is 0, so that does satisfy it. So we do implicit differentiation. So you get 2x minus 3y squared y prime is equal to 0. Let's do this normally. Here we do it normally, and then multiply by y prime. So y prime is going to be equal to negative 2x divided by 3y squared by negative 3y squared. So this becomes negative when we move it from here over there, and then when we divide by that. So we can 2x over 3y squared. Okay, so what is the value of the derivative at that point? You just plug the numbers in. So 2 times 1 divided by 3 times 1 squared, which is just 2/3. So that's the slope of the tangent line to this curve at x equals 1, y equals 1. Let's see my cursor here. Take my glasses off. There we go. Found it. Okay, we're on 23. It's another one of these where we do their derivative and then just plug the numbers in. So the function, or not the function, but the relationship is x squared minus 4 over x squared plus 4. And when x equals 2, y equals 0. Okay, so how do we implicitly differentiate this? Well, this one's easy. You get 2y, y prime. And on the right-hand side, you have to use the quotient rule. So let's remember what that is. You take the derivative of this, 2x, times the denominator, minus the derivative of the denominator, which is 2x, times the numerator, all divided by the numerator squared. So let's just clean up a little bit in the numerator. So we get 2x cubed plus 8x minus 2x cubed. All right, minus 2x cubed plus 8x, all divided by x squared plus 4 squared. Finally, combining like terms, these cancel out. 8 plus 8 is 16, so we get 16x divided by x squared plus 4 squared. And then we divide both sides by 2y. So we get y prime is 16x divided by 2y times 1 over x squared plus 4 squared. Of course, 8 divided by 16 divided by 2 is 8, so we get 8x divided by y times x squared plus 4 squared. Okay, let's check the answer. 8x over y, x squared plus 4 squared. That's it. So if we plug in 2 and 0, so we could put like 2 comma 0 if we wanted to, you get 8 times 2 divided by 0 times 2 squared plus 4 squared. Okay. 16 divided by 0, undefined. So you probably have a vertical line, vertical tangent line. And what did they say in the book? They just say it's undefined. Okay, so this is the problem number 25. So we have x to the 2/3 plus y to the 2/3 equals 5.8 comma 1. So if you plug in 8 for x, you'll have 8 to the 2/3, so that's the cube root of 8, which is 2. 2 squared, which is 4. So 4 plus 1 to the 2/3, which is 1. 4 plus 1 equals 5, so that does work out. So we're going to take the derivative with respect to x of each term. So when we deal with the one that's just x, we just use the normal power rule. And this one we're going to have to use implicit differentiation. So you get the exponent times 1 minus the exponent, or the exponent minus 1. You get the same thing here, 2/3 x, y to the negative 1/3, but then you end up with this y prime term. And the right-hand side is 0. So then we need to solve for y prime. So we'll move the stuff that's not involving y prime to the other side. You can see that 2/3 is going to cancel out. So let's just go ahead and do that now. I haven't changed them back to the cube root, or I will at some point. So now you divide both sides by this term, so you'll get negative, and what you could do is x over y to the negative 1/3 power. So I'm dividing by y to the negative 1/3. And then you could flip these over. So switch y and x. So you get y over x to the positive 1/3 power. And then if you wanted to, you could rewrite that as a cube root if you wanted to. Cube root of y over x. So evaluating this at 8 comma 1, you'd find that the derivative is equal to negative the cube root of 1/8. So y is 1, x is 8. And the cube root of 8 is 1/2. So you get y prime is equal to negative 1/2. Okay, now we have this group in this 33 and 36. So 36, they show you what it looks like. So because y is squared, we get a parabola going the other direction. So if you want a parabola going this way, or down or up, you have x squared. If you want a parabola going sideways, then you have y squared. Okay, so they want to find the equation in the tangent line at the given graph. So the point is shown in the graph at 4, 0. So that's our x1 is equal to 4. Our y1 is equal to 0 when we use a point slope form. But we need to find the derivative. We need to find y prime, which is the slope of the tangent line. Now, how do we do that? Well, you could multiply this out with FOIL. The other option is to use the chain rule. So I'm going to use the chain rule. So what you do is take the exponent to multiply by determine the parentheses, reduce the exponent by 1, multiply by the derivative of what's in here. The derivative of -2 is 0. The derivative of y is y prime. Now over here, probably easier just to multiply it out. 4x minus 12. So the derivative of 12 is 0. The derivative of 4x is 4. And this, of course, is y minus 2 to the first power. So if we divide both sides by this, we'll solve for y prime, and we'll get 4 divided by 2 times y minus 2. And of course, 4 divided by 2 is 2, so you get 2 over y minus 2. Now, what we'd expect is the slope to be a negative number. It looks like almost -1, just based on eyeballing it, because it looks like about a 45-degree angle. So let's see what happens. So y prime at x equals 4, y equals 0 is 2 over 4 minus 2, which is, I got a problem here. What did I do wrong? Why am I thinking this is a problem? Because I'm thinking that I should have a negative slope at that point. So I'm doing something is wrong. Oh, because I plugged x in. That's why it didn't work. Okay. Y is 0, not x is 0. Okay. 2 divided by y, which is 0 minus 2. 2 over -2 is -1. So that's what I was expecting. Oh, wait. We haven't found the equation for the tangent line, have we? We found the slope. But we need to go one step further. So let's do that. So then all we do is use the point slope linear equation, which is this. We just say that m is -1. And we've already got x1 and y1, so we plug that in there. So we have y minus 0 is equal to -1 times x minus x1, which is 4. So you get y is equal to -x minus 4 plus 4. Again, if you look at the curve, you can see that if you draw a line about a 45-degree angle with a negative slope, that it's going to go up and intersect the y-axis at about y equals 4, which is the y-intercept. Okay, now I'm finished. Okay, now we're going to number 36. And again, if you look at the curve, you see that point negative, or square root of 3, 1. And so again, your tangent line is going to be a negative slope. It looks actually like -1 again, so I wouldn't be surprised if we get the same slope. Of course, the equation for the tangent line is going to be different because we have a different x and y value. So we have that square root of 3 xy plus 13 y squared minus 16 equals 0. So that's interesting because it's actually the equation for a hyperbola or ellipse that's rotated. Okay, anyway. So we do implicit differentiation, and the point is that we're looking at is square root of 3, 1. So how does this work? Take the derivative of that, you get 14x. You have your constant, and you've got a product, x times y. So you take x times the derivative of y plus y times the derivative of x. So that's the product rule. First term times the derivative of the second. because it's just y by itself is what you get. Then take the second term times the derivative of the first. Then we have 13 times 2y, and then we add the y prime in. We have 0 from here, and 0 derivative of 0 is 0. So let's multiply this out. So we get 14x. This is minus. So you get negative 6 times the square root of 3x y prime minus 6 square root of 3 y plus 26 y prime is equal to 0. Okay, again, these two involve y prime, so those will stay on the left-hand side. These don't involve y prime, so those go to the other side. So you get negative 6 square root of 3x y prime plus 26 y prime is equal to, okay, when this goes to the other side, it becomes negative 14x, and this one becomes positive 6 times the square root of 3. Times y. Factor out y prime. Make the right-hand side the same. Okay, just check here. This is times that, this times that, times that is that. So everything works out, then you solve for y prime. So we'll get negative 14x plus 6 times the square root of 3y, all divided by negative 6 square root of 3x plus 26y. So that's the result. And then to find the slope of the tangent line, you plug in x equals the square root of 3 and y equals 1. So we'll get negative 14 times the square root of 3 plus 6 times the square root of 3 times y, which is 1. Negative 14 times the square root of 3 plus 6 square root of 3 times y. Okay, that looks good. Then you get negative 6 square root of 3 times x, which is the square root of 3 plus 26 times y, which is 1. So on top we get y prime is equal to negative 8 square root of 3. Negative 14 plus 6 is negative 8. Here we get 6 times 3 times square root of 3 times square root of 3 is 3. So I actually get negative 18 plus 26. So you get negative 8 square root of 3 over 8. You get negative the square root of 3, which is the square root of 3 is 4.78 something or other, 728 I think. Square root of 3, 1.732. So it's negative, which we expected, 1.732. I guessed it as negative 1, but probably if I looked at it more closely, it probably is a little steeper than that. We'll check the answer. Make sure we're okay. 36. Negative the square root of 3. Okay, so I got that right. Now, equation of the tangent line. So m is equal to negative the square root of 3. The point was the square root of 3 comma 1. So this is x1. This is y1. That's m. So obviously it's a piece of cake here to just plug it in. So we get y minus y1 is equal to m times x minus x1. So y minus 1 is equal to negative the square root of 3x. Negative is positive, positive 3 So solve for y, we'll get negative the square root of 3x plus 4. So if you look at the graph, you can see the y-intercept is going to be positive 4, which makes sense. You can look at that and say, oh yeah, that's probably with the slope of 1.7 something. It looks like it's around 4. Okay, last problem in the section on implicit differentiation is that other thing that we do, which is find the points where we have a horizontal tangent line or vertical tangent line. So horizontal tangent line means horizontal means y prime is equal to 0, and vertical is y prime is undefined because it's divided by 0. So this would be when the numerator goes to 0, and this is when the denominator goes to 0. And this is an equation for an ellipse, so this should be 2 of each. 25x squared plus 16y squared plus 200x minus 1600, 160y plus 400 equals 0. Take the derivative. 2 times 25 is 50. So I get 50x from that. 2 times 16 is 32y prime. The derivative of that is 200. The derivative of that is 160y prime. The derivative of a constant is 0, and you get 0. So these two terms involve y prime, so let's just leave them where they are. 32y prime minus 160 y prime is equal to negative 50x minus 200. Factor out y prime, 32y minus 160. Solve for y prime. Negative 50x minus 200 divided by 32y minus 160. So for horizontal lines, horizontal tangent lines, R is on 2. So for the horizontal tangent lines, you have that negative 50x minus 200 is equal to 0. So that gives you 50x is equal to negative 200, or x is equal to negative 4. So that's the x values, and there are two. If you put in negative 4, you can solve for 2 y values associated with that, which I'm going to do in a second. But first we're going to do the vertical tangent lines. You don't have to do this. Again, this is, okay, vertical tangent. That's when 32y minus 160 equals 0. So you get y is equal to 160 over 32, which is 5. Right? Yep, 5. So y is equal to 5. So that's where you have vertical tangent lines. Does that make sense? Well, we have to find the corresponding, there's one value of y and there are 2 values of x. So let's go figure out what the x values are, the y values are in this case. So what we do is we go back to the original equation and we substitute in for x. So what I'm doing here is I'm substituting negative 4 in. And what I end up with is a quadratic equation, which I can solve numerous ways. So let's see what we get here. 25 times 16, that's 400. 400 plus 16y squared minus 800 minus 160y plus 400 equals 0. Okay, so 400, 400 minus 800, those all cancel out. So you end up with 16y squared minus 160y is equal to 0. You can factor 16y out, so you'll get 16y times y minus 10 is equal to 0. So there are two solutions, y equals 0 and y equals 10. So what we know is that there are horizontal tangent lines at x equals -4, y equals 0, and x equals -4, y equals 10. So those are the exact points. Then we can go back for the second one and substitute y equals whatever we got. So let's just do that. Let's copy this. So there's your vertical and tangent line case. Okay, so let's plug in y equals 5. 25x squared plus 16 times 5 squared plus 200x minus 160 times 5 plus 400 equals 0. So 25x squared. Second term becomes 400 plus 400 plus 200x minus 160 times 5 is 800 plus 400. 400 plus 400 is 800. Subtract 800, you get 0. So the same kind of thing happens. So you get 25x squared plus 200x is 0. Factor out 25x, and you get x here, and you get 8 plus 8. 25 times 8 is 200. So you have two x values, x equals 0 and x equals -8. So the coordinates are going to be 0, 5 and -8, 5. These turn out to be the vertices of the, is that what they're called? Yeah, the vertices of the ellipse as well. So here you're going to have vertical tangent lines. And so let's actually plot these things. So let me put a page in. I'm putting a piece of graph paper. Graph. Okay, so there we go. So let's plot them. So the first plot was 0, 5 and -8, 5. Okay. 0, 5, 1, 2, 3, 4, 5. And then -8, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so those are the x vertices. And then the other one, the other coordinates, I wrote down here somewhere. Oh yeah, right here. We're -4. Where did I write this? Oh, -4, 0, and -4, 10. So -4, 1, 2, 3, 4, 0, and -4, 10, which is up here. So it looks something like this. It's pretty close to a circle, but not quite. Because you have 8 units here, you have 10 units there, so it's a little bit longer in the y direction. And the center of the ellipse would be right, the intersection of these two lines would be right there. So the center is at -4, 5. So that's what happens.